Hello everybody. Now we shall discuss about Schering Bridge. This bridge is having three capacitances, three capacitors. E is the supply voltage, AC voltage given to this bridge. This is R1, small r1. C1 is the capacitance of this capacitor. C2 is the capacitance of this capacitor. C4 is the capacitance of this capacitor. R4 is the resistance of this resistor. R3 is the resistance of this resistor. Let I1 is the current flowing to this, I3 is the current flowing to this. Under balance conditions, I3 will be equal to I1. Okay, I2, and this will be I4, this will be IR, and this will be the current which is flowing to this will be IC. Voltage across this branch is E1. Let E1 is the voltage across this branch. E3 is the voltage across this branch. E2 is the voltage across this branch. E4 is the voltage across this branch. Here R4 and C4 are variables. Okay. After getting balance equations, we'll come to know why we choose these two as variables. Okay. Now this bridge is used for the measurement of capacitance of impure capacitor. Okay. This bridge is used to make measurements on impure capacitor or imperfect capacitor. Okay, this bridge can be used for the measurement of capacitance. Okay, now what is this R1? R1 R1 is equal to, okay, first let me C1 is equal to capacitance to be measured is C1. Capacitor whose capacitance is to be measured, is to be determined, or is to be measured is C1. What about R1? It is a series resistance representing the dielectric loss in the capacitor C1. This represents dielectric loss. R1 represents, here we place impure capacitor. Combination of these two is nothing but impure capacitor. Impure capacitor consisting of resistance as well as capacitance. Okay, so this R1 you're not separately, you're not connecting separately this R1. Okay, you're not connecting this R1 separately to this C1. Okay, just you are placing impure capacitor. Okay, impure capacitor is the series combination of these two. Okay, so this R1 represents dielectric loss in the capacitor C1. Okay, this R1 represents dielectric loss in the capacitor C1. Okay, coming to C2. C2 is a standard capacitor, and it is pure capacitor. C2 is pure capacitor as it is having no dielectric loss. Okay, pure capacitor means we use air or gas capacitor. Okay, air or gas capacitor will be pure capacitor. Okay, having no dielectric loss. Okay, this will be having no dielectric loss. Okay, without dielectric loss. This is a capacitor which is having no dielectric loss. Okay, capacitor without dielectric loss is pure capacitor. Okay, here C2 is pure capacitor. Coming to R3. R3 is non-inductive resistance. Non-inductive resistance. Okay, C4 is variable capacitor, whereas R4 is also a variable. It is also a variable non-inductive resistance. Non-inductive resistance in parallel with variable capacitance. Okay, in parallel with variable capacitor C4, in parallel with variable capacitor C4. Okay, at balance, under balanced conditions. Okay, at balance we know Z1 Z4 is equal to Z2 Z3. What is Z1? Z1 is equal to R1 plus 1 by j omega C1. What about Z4? Z4 is the parallel combination of resistance and capacitance, right? Okay, then R4 into 1 by j omega C4 by R4 plus 1 by j omega C4, which is equal to what is Z2? Z2 is 1 by j omega C2. What is Z3? Is R3. Okay, now this will be 1 plus j omega C1 R1 by j omega C1. This will be R4 by 1 plus j omega R4 C4 into R3 by j omega C2. Both will get cancelled. Okay, then this will be bring this term on this side, bring this term on this side. Okay, then you're going to get R4 C2 plus j omega C1 C2 R4 R1 which is equal to C1 R3 plus j omega C1 R3 R4 C4. Equate both real and imaginary parts separately. What is the real part over here? On RHS, this is the real part. Okay, so R4 C2 is equal to C1 R3. R4 C2 is equal to C1 R3. Okay, from this C1 is equal to R4 by R3 into C2. This is C1. Okay. Now comparing imaginary parts C1, C2, R4, R1. C1, C2, R4, R1 is equal to C1, R3, R4, C4. C1, R3, R4, C4. Okay, both will get cancelled. Both will get cancelled. From this, R1 is equal to R3 C4 by C2. R3 C4 by C2. This will be R1. Now let us find dissipation factor. D factor or derating factor or dissipation factor which is equal to tan delta, which is equal to omega C1 R1. Okay, which is equal to omega, what is C1? R4 by R3 into C2 into what is R1? R3 C4 by C2. Okay, then you are going to get tan delta. Okay, dissipation factor, D factor is equal to omega R4 C4. This bridge can be used for the measurement of capacitance of impure capacitor. Okay, this bridge, these are all the applications. Coming to the applications of this bridge can be used for the measurement of capacitance of underground cables. This bridge can also be used for the measurement of relative permittivity. Can be used for the measurement of relative permittivity permittivity of dielectric material of dielectric materials. Okay. Now let us draw the phasor diagram. Fine. Now let me take current as reference vector. I am taking I1 as reference vector. So I1 as reference vector. So this will be what? This is I1. I am taking I1 as reference vector. Okay. And now let us consider this branch first. How can I draw the phasor of voltage across this resistance? Okay. Voltage across this resistance will be in phase with I1. I1 is the current flowing through this resistance. So voltage across this resistance will be in phase with this I1. Will be in phase with the current which is flowing through this R1. Okay, so that will be in phase. So now let us draw voltage across R1. Okay, so this will be voltage across R1. Okay, I1 R1. Okay, now how can I have the phasor of voltage across this capacitor? We have phasor of I1, phasor I1. Let us have the phasor voltage across this capacitor. Okay, voltage across this capacitor lags current by an angle 90 degrees. So voltage across capacitor lags current by an angle 90 degrees. So I1 is the current which is flowing through the capacitor. So this will be what? This will be voltage across this C1. Voltage across C1. Okay. So this will be I1 by omega C1. I1 by omega C1. Okay, now fair sum of voltage across this and voltage across this gives E1. Okay, so fair sum of this and fair sum of voltage across resistance and capacitance gives E1. So this will be E1. E1. This will be E1. E1, which is equal to E2. E1, which is equal to E2, which is equal to voltage across this capacitor, right? That is I2 by omega C2. Okay. E1 is equal to E2, equal to I2 by omega C2. Okay. Now, how can I draw the voltage across this resistance? Phasor of voltage across this resistance. Okay. Anyhow, I1 is equal to I3. I1 is equal to I3. Okay. So, voltage across this resistance will be in phase with current flowing through this resistance. So, in phase with I1. So, this will be E3. E3 E3 which is equal to E4, which is equal to E4. Okay, and which is equal to, what is E4? E4 is equal to IR into R4. IR into R4. I'll do one thing. Let me write over here. Okay, I'll write over here. E3 is equal to E4, which is equal to IC by omega C4, which is equal to IR R4. Okay. Okay, now coming to this, how can I have this IR? We have phasor E4. Phasor E4 is there. How can I have this IR? Anyhow, this E4 will be in phase with IR because E4 is the voltage across this R4. Okay, then E4 will be in phase with IR. So this will be IR. This will be IR. Okay. Now, how can I have phasor IC? IC is the current flowing through this. We have E4. E4 is the voltage across capacitor. E4, this is the E4, phasor E4 is the voltage across this capacitor. How can I have this phasor IC? Current leads voltage by an angle 90 degrees. Current to the capacitor leads voltage across the capacitor by an angle 90 degrees. So this will be IC. IC. Now I4 is the fair sum of IC and IR, right? Okay, so fair sum of IC and IR, IC and IR will be I4, will be I4. So this will be I4. I4, this will be I4, which is equal to I2. Directly you can write I2 also. Okay, I4 is equal to I2. This will be I2. I4 is equal to I2. Okay. Now, What is E? Total E. Total E is the fair sum of E1 and E3. E1 and E3 or E2 and E4. Okay, fair sum of E1 and E3. Okay, E1 and E3, right? So fair sum of E1 and E3. Okay, E1 and E3. E1 and E3. E1 and E3 is okay. So this will be E. Okay, E is the fair sum of E1 and E3 or E2 and E4. Okay, now what will be the angle delta? Okay, uh, delta is the angle between voltage across capacitor and E1. Okay, voltage across capacitance of impure capacitor is VC1 or I1 in I1 by omega C1. This is nothing but VC1. Okay, and total voltage across the impure capacitor will be E1. So the angle between these two will be delta. The angle between these two will be delta. Okay, angle between voltage across capacitance of impure capacitor and voltage across impure capacitor. That is the combination of capacitance and series resistance is E1. Okay, angle between VC1 and E1 will be delta. Okay, thank you.